current draw of the water heater can be calculated using the formula current equals power divided by voltage. For a 240 volt circuit, the current draw is 4,500 watts divided by 240 volts, which equals 18.75 amps. This calculation assumes both elements are operating simultaneously. This is a theoretical maximum. Now, whether a 30 amp circuit is sufficient depends on several factors. While the calculated current draw of 18.75 amps is below the 30 amp rating, electrical codes typically require that the circuit breaker be sized at 125% of the continuous load. A water heater is considered a continuous load if it operates for 3 hours or more. To determine the appropriate circuit breaker size, multiply the current draw by 1.25. So 18.75 amps times 1.25 equals 23,4375 amps. A 30 amp circuit breaker would appear sufficient since 23,4375 is less than 30, but this assumes the elements never draw more current than the nameplate rating and doesn't account for any other loads on the circuit. However, water heaters rarely operate with both elements on at the same time for extended periods. Most of the time, only one element operates to maintain the water temperature. So, a 30 amp circuit might function without tripping the breaker. However, given the issues experienced and to ensure safety and prevent nuisance tripping, it is recommended to increase the circuit breaker and wiring size to 40 amps. Here's why that's a good idea. Firstly, safety margins. Electrical codes prioritize safety. By increasing the circuit breaker size, you create a larger safety margin and reduce the risk of overheating the wires or tripping the breaker due to temporary surges. Secondly, future-proofing. If there are plans to upgrade the water heater or add other electrical loads to the circuit in the future, a larger circuit breaker provides greater flexibility and avoids the need for costly rewiring later. Thirdly, code compliance. Local electrical codes might have specific requirements for water heater circuits. Consulting a qualified electrician to ensure compliance with all applicable codes is always the best practice. Now, to install the 40 amp circuit, you will need to replace the existing 30 amp circuit breaker with a 40 amp circuit breaker. The wiring must also be upgraded to a size suitable for 40 amps. Typically, this requires using number 8 American wire gauge copper wire or number 6 American wire gauge aluminum wire, but refer to the National Electrical Code Table 310.15b16 or a local electrician for the appropriate wire size based on the specific installation conditions, such as the wire insulation type and ambient temperature. The fuse disconnect should also be replaced with one rated for 40 amps. The fuses must also be 40 amp time delay fuses, often referred to as slow blow fuses. The steps to perform this upgrade are as follows. Firstly, turn off the main breaker. Before starting any electrical work, turn off the main breaker that supplies power to the entire electrical panel. This ensures that you are working with no live electricity, reducing the risk of electric shock. Secondly, remove the existing 30 amp breaker. Carefully remove the existing 30 amp circuit breaker from the electrical panel. Loosen the screw that secures the wire to the breaker and then pull the breaker out of the panel. Thirdly, disconnect the existing wiring. Disconnect the wiring from the existing 30 amp fuse disconnect. Make sure the wires are safely disconnected and properly insulated. Fourthly, install the new wiring. Install the new number 8 American wire gauge copper or number 6 American wire gauge aluminum wiring from the electrical panel to the new 40 amp fuse disconnect. Ensure the wiring is properly secured and routed through the appropriate channels. Fifthly, install the new 40 amp fuse disconnect. Install the new 40 amp fuse disconnect in place of the old one. Connect the wiring to the disconnect, ensuring that all connections are tight and secure. Sixthly, install the new 40 amp circuit breaker. Install the new 40 amp circuit breaker in the electrical panel. Connect the wiring to the breaker, ensuring that all connections are tight and secure. Seventhly, test the circuit. After completing the installation, turn the main breaker back on and test the circuit to ensure that it is working properly. Use a multimeter to verify the voltage and current at the water heater. Remember, working with electricity can be dangerous. If you are not comfortable performing this upgrade yourself, it is best to hire a qualified electrician. They will have the knowledge and experience to ensure that the work is done safely and correctly. It is crucial to adhere to the National Electrical Code and local electrical codes when performing any electrical work. These codes provide detailed guidelines for safe and proper installation practices. Local codes might have more stringent requirements than the National Electrical Code, so it is essential to be aware of them. In addition to the above steps, consider the following. Firstly, proper grounding. Ensure that the water heater and all electrical components are properly grounded. Grounding provides a path for stray electricity to flow back to the source, reducing the risk of electric shock. Secondly, conduit and protection. Protect the wiring from physical damage by running it through conduit or other protective materials. This is especially important in areas where the wiring might be exposed to impact or abrasion. Thirdly, labeling. Label the new 40 amp circuit breaker and fuse disconnect so that they are easily identifiable in the future. This helps prevent confusion and ensures that the correct circuit is turned off when performing maintenance or repairs. Fourthly, professional inspection. After completing the upgrade, have a qualified electrician inspect the work to ensure that it meets all applicable codes and standards. This provides an extra layer of safety and peace of mind. In summary, while a 30 amp circuit might technically be sufficient for a water heater with a current draw of 18.75 amps, upgrading to a 40 amp circuit provides a greater safety margin, allows for future expansion, and ensures compliance with electrical codes. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns. Remember to use the appropriate wire size, fuse disconnect, and circuit breaker, and follow all applicable codes and standards. By following these guidelines, you can ensure that your water heater is operating safely and efficiently. It's important to understand the difference between the upper and lower wattage ratings on the water heater nameplate. The 4,500 watts at 240 volts and 3,880 watts at 208 volts indicate the power consumption at different voltage levels. If the home is supplied with 208 volts, then the lower wattage rating should be used for calculating the current draw. This would result in a lower current draw, but the same principles apply for determining the appropriate circuit breaker size. Also, consider the type of fuses used in the fuse disconnect. Time-delay fuses, also known as slow-blow fuses, are designed to withstand temporary overloads without tripping. These are ideal for water heaters because they can handle the initial surge of current when the elements first turn on. Regular fuses might trip unnecessarily due to this surge. Ensure that the fuses are properly sized and rated for the circuit. Another important factor to consider is the condition of the electrical panel. If the electrical panel is old or in poor condition, it might not be able to handle the increased load of a 40 amp circuit. Inspect the panel for any signs of damage, such as corrosion, loose connections, or overheating. If any issues are found, it might be necessary to replace the entire electrical panel. Replacing the electrical panel is a more complex and expensive undertaking, but it can significantly improve the safety and reliability of the electrical system. It's also crucial to verify that the water heater is properly installed. Ensure that all connections are tight and secure, and that the water heater is properly grounded. Loose connections can cause arcing, which can lead to overheating and fires. Proper grounding is essential for preventing electric shock. Check the water heater's installation manual for specific instructions on how to properly install the unit. Ignoring the manufacturer's instructions can void the warranty and create a safety hazard. When selecting a new water heater, consider energy efficiency. Look for models with a high energy factor or uniform energy factor. These models are designed to use less energy, which can save money on utility bills. Energy-efficient water heaters often have thicker insulation and more efficient heating elements. While they might cost more upfront, they can pay for themselves over time through reduced energy consumption. Consider the size of the water heater. A 50-gallon water heater is suitable for most households, but larger families might need a larger capacity. A water heater that is too small will run out of hot water quickly, while a water heater that is too large will waste energy by heating water that is not needed. Calculate the hot water demand based on the number of people in the household and their usage habits. Also, consider the type of water heater. Electric water heaters are common, but there are also gas, propane, and tankless water heaters available. Each type has its advantages and disadvantages. Gas and propane water heaters typically heat water faster and are more energy efficient, but they require a gas line and venting. Tankless water heaters provide hot water on demand, but they can be more expensive to install and might require upgrading the gas line or electrical service. Weigh the pros and cons of each type before making a decision. Finally, consider the warranty. Water heaters typically come with a warranty that covers parts and labor. Read the warranty carefully to understand what is covered and for how long. Some manufacturers offer extended warranties for an additional cost. An extended warranty can provide peace of mind, but weigh the cost against the likelihood of needing repairs. In conclusion, determining the appropriate circuit breaker size for a water heater involves calculating the current draw, considering the continuous load factor, and adhering to electrical codes. While a 30-amp circuit might seem sufficient, upgrading to a 40-amp circuit provides a greater safety margin and allows for future expansion. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns. Remember to use the appropriate wire size, fuse disconnect, and circuit breaker, and follow all applicable codes and standards. By following these guidelines, you can ensure that your water heater is operating safely, efficiently, and reliably. If the water heater has been blowing fuses repeatedly, it is crucial to address the underlying issue. While upgrading to a 40-amp circuit might prevent nuisance tripping, it does not solve the problem if there is a faulty component or wiring issue. Inspect the water heater for any signs of damage, such as leaks, corrosion, or loose connections. Test the heating elements and thermostats to ensure they are functioning properly. A faulty heating element can draw excessive current, causing the fuse to blow. A malfunctioning thermostat can cause the water heater to overheat, which can also lead to blown fuses. If any faulty components are identified, replace them immediately. Continuing to operate the water heater with faulty components can create a safety hazard and damage the unit. It's also important to check the wiring connections to the water heater. Loose connections can cause arcing, which can lead to overheating and fires. Ensure that all connections are tight and secure. If the wiring is old or damaged, it should be replaced. Old wiring can become brittle and cracked, which can increase the risk of electrical shorts. When replacing wiring, use the appropriate gauge and type of wire for this circuit. Refer to the National Electrical Code for guidance on wire sizing. If the water heater is located in a damp or humid environment, it is important to protect the electrical components from moisture. Moisture can cause corrosion and electrical shorts. Consider installing a waterproof enclosure around the electrical components or applying a moisture-resistant coating to the wiring. Also, ensure that the water heater is properly grounded. Grounding provides a path for stray electricity to flow back to the source, reducing the risk of electric shock. Check the grounding connection to ensure it is secure and free from corrosion. If the water heater is connected to a metal water pipe, the pipe should also be grounded. Finally, consider the age of the water heater. Water heaters typically last for 10 to 15 years. If the water heater is nearing the end of its lifespan, it might be more cost-effective to replace it rather than continue to repair it. Newer water heaters are often more energy efficient and have improved safety features. Replacing an old water heater can save money on utility bills and reduce the risk of electrical problems. In summary, if a water heater is blowing fuses repeatedly, it is crucial to address the underlying issue. Inspect the water heater for any signs of damage, test the heating elements and thermostats, check the wiring connections, protect the electrical components from moisture, and consider the age of the water heater. Addressing these issues can prevent future problems and ensure the safe and reliable operation of the water heater. Always consult with a qualified electrician if you have any doubts or concerns.